With that, I will hand it over to Karthik to start the session.
Thank you very much. Thank you so much, Nilesh, and thanks a lot to everyone for joining here. Like Nilesh said, my name is Karthik. I've been in the industry for a little over a decade now, and most of my work has been in introducing EVs into fleet applications. And what I mean by that is you're taking a vehicle and making money out of it. That's essentially what we focus on in this case. Not so much about individual personal mobility, but fleet applications of electric vehicles. The reason this is important, and we'll kind of speak a little bit about that, is we believe that in many markets, personal mobility is the focus for electrification today from OEM's perspective, especially in developed economies. But developing economies have a different trajectory as well, and it's starting to emerge in a very big way in the developed markets as well. So the focus of today's conversation is really about what is the kind of challenges that one can potentially face in the electrification of commercial fleets. The course, it's sort of basically setting the foundation for the actual course itself as to how do we navigate through those challenges. Um, there are not always solutions, but the problems that need to be managed. So we will walk through that. So let me get going straight away. I'm more than happy to take questions as and when you have them. You can either post them in the chat box. I can't see it, but one of my colleagues would prompt me. Or if you wish to unmute yourself and speak up, that's fine as well. So let me get started with this. Um, right. So broadly, what we will be talking about today is the broad market context in a very summary fashion. Who are the stakeholders that are relevant for fleet application? I'll be touching upon three aspects of three kinds of challenges. The challenges that emerge from the technology, the intrinsic technology of an EV, the business models and financial. There are several other aspects as well, but in the interest of time, I'll be focusing on these three aspects. And from this, deriving what's the kind of course outline that the actual course, the 12-week course that it does. So, what is it that's driving electrification? So, if we kind of look at how transportation is being transformed with electric mobility, there are, of course, and this is just a particular way of framing the theory of change. There are many ways to slice and dice this. It's just one particular way to think about it. I think essentially there have been a lot of environmental concerns that are generally driving electrification, a need for electrification. Certain countries are looking at electrification also from an energy security perspective. What I mean by that is that many countries are dependent on oil imports for their energy requirements, which imposes a significant constraint on them in terms of foreign exchange requirements. And it is this that is also driving countries to support policies for electrification, because then your energy um, requirements can be met locally. So that's another thing. And of course, an enabler of all of this has been battery technology progress. In mid 90s, electric vehicles were tried out in California, for example, but they were using lead acid batteries. The batteries were just not ready for prime time for the kind of usage that automobiles demand. So I think the emergence of lithium ion batteries as the mainstay of battery technology for electric vehicles has clearly been a huge driver of the electrification process itself. There have been a set of enablers that have come together in this process. Of course, governments have come in with their regulations, with subsidies to support electric mobility. With that queue in place, OEMs and supply chain investments have started to pick in, which has started to create economies of scale, which has in turn led to price drops, which makes electric mobility a little bit more affordable. And the third thing is, especially which is true for fleet applications, is the emergence of new business models and financing. I'll speak a bit about this. I'll just hold off for now. As a result of this, we are starting to see this whole virtuous cycle of adoption of electric mobility. That is, it's driving adoption. As adoption gets increased, scale gets created, which is kind of amplifying the whole process. But what is interesting to note is that the trajectories are different. In the developed economies, we have seen personal cars being the focus of electrification, and then now it's sort of commercial vehicles that are starting to come into play. Emerging markets, the story is exactly the reverse. It's primarily been focused on commercial fleet applications, of course, with smaller form factor vehicles. And personal vehicles are expected to be a follow up to commercial fleet adoption. And what is common across both developing and developed markets is an interest in electrification of public transport, especially using electric buses. So this is something that has sort of been a common thread across developing and developed markets. So what we are seeing today is that in terms of fleet applications, this is basically projections from the latest BNEF, the Bloomberg New Energy Finance report, EV Outlook 2021. So I just want to kind of look at the e-buses and commercial EVs. What you're seeing today is that around 1 million of them, which is going to get close to 6 million in the next 5 years, which is almost like a 5x increase in the penetration of EVs in this sector, which is very comparable, by the way, to passenger EVs as well. And then there is, of course, 2 and 3 wheelers, which are more a developing market phenomena. But there is from a volume perspective, there is a massive increase, but a lot of it is already coming in. The red is China. So there's already a huge adoption that has taken place in China, but there's an incremental improvement over that in the rest of the world. But if you look at the other in buses and commercial AVs, it's a little bit more spread out beyond China into US, Europe, and other regions as well. So I think from an opportunity perspective, from the kind of projected scale that's going to happen, I think this is clearly something that, I mean, in terms of volumes today, you see that passenger EVs are already far more than commercial, but in terms of the rate of change of growth, e-buses and commercial EVs are clearly poised to grow very significantly. And that's sort of why one of the other reasons for the focus of this course. In terms of government incentives, I basically wanted to touch upon why are governments interested in supporting electric mobility. I think if we look at it, there are a few reasons that come up. Of course, environment is one of the big reasons why countries are looking at supporting electric mobility. It is helpful to understand that the environment question is to be looked at in two aspects. The first is, of course, the impact on greenhouse gas emissions. And that varies to a degree depending on how clean your grid is. So depending on the national grid emissions factors, the introduction of EVs would have a greater or a lesser improvement. But in general, it has been shown from at least the analysis that I've seen that there is more or less a positive improvement on the GHG or CO2 emissions perspective. But the other more important thing that a lot of governments and especially cities are focusing on is also the quality of air, the improvement in the air quality. I think especially with COVID lockdowns, a lot of cities experienced immensely improved air quality, and that has also created this awareness about how impactful EVs can be because their tailpipe emissions are zero. The second point I mentioned about energy security. So this is clearly one of the other reasons why many governments want to move away from a dependence on oil producing nations and localize their energy sources through electricity generation, and therefore move transport away to an electric source helps them in that sense. The third is interesting. It is basically about resource exploitation. So a lot of countries, so with the emergence of electric mobility, you have new kinds of minerals starting to become important: lithium, nickel, manganese, cobalt, and in some cases rare earth materials as well. So I think many of the new countries that were otherwise not a part of the energy value chain traditionally globally are now having an opportunity to come in and play a role. So for example, Indonesia has one of the largest deposits of nickel, and nickel is a very important component of batteries. So lithium ion batteries, or at least a particular chemistry of that. So they are now trying to become a dominant player in that value chain. So there is that motivation from a government perspective to look at incentivizing electric mobility. The last bit is a very subtle and important one, and it is basically coming from a couple of countries only. Basically, China, for example, was very clear that the 21st century automotive technology is in some form is going to be electric. It could be electric with batteries and at some point in time move towards hydrogen. And it gives them an opportunity to create a dominant position in an industry that was otherwise conventionally dominated by only three blocks: the Japanese, the Europeans, and the Americans. So now, when your 60% of your BOM is the bill of materials is completely changed, it creates a greenfield opportunity for a country to come in and play that market at scale, at a global market. And that global dominance has also been a driving factor in the way they have invested and government money into creating the complete entire ecosystem and value chain and take a dominant role in that position. From a business and an individual perspective, so why should businesses and individuals care? Obviously, I think from a business perspective, what we will see is that fleets of electric vehicles provide you a lower total cost of ownership. That's a very important thing for fleets. They make more money by, in the long run, they make more money by adopting electric vehicles. The second important aspect is your today in many countries with oil prices going up again after COVID, it's starting to increase again and hit. So there is a significant up and down on the cost of fuel. With electricity prices, it's not that volatile, and therefore you have a near inflation-proof operating cost. So you're able to project your costs going forward from a fleet point of view, and that's very helpful. Environment is important. So I think from a commercial fleet application perspective, clearly you are able to save money while doing good. And I think that feels good. It doubly makes you feel happy. So that's the reason from a multiple perspectives why fleet applications are becoming important for electric mobility. What is
Karthik,
an important concept here is this whole notion of total cost of ownership, where it's not just about the upfront price, but the upfront price plus the running cost over a period of time. That becomes an important metric for driving fleet adoption. So you kind of need to look at the capital expense, the cost of finance for buying and operating vehicles and infrastructure, plus the running cost, which could include fuel, maintenance, and other aspects, insurance, and there is a residual value component that in case if you're selling off a vehicle after a period of usage, you kind of take that back. In the case of ownership of vehicles, you also get depreciation benefits and all of that. So I think that the whole package is something that people have to look at. And that starts to become better. It starts to save you money. In this example here, it's showing a 4.4-year break even for a light commercial vehicle below 1.5 tons relative to a diesel van. So, I mean, if you had a comparable vehicle doing comparable operations, after 4.5 years, you are better off running an EV. Especially this is
Karthik,
true. Yeah, please.
is this already true for individuals and passenger vehicles in all geographies?
Not in all geographies. It depends on a lot of factors, depending on the availability of the vehicle, the cost of the vehicle, cost of fuel in your country, the cost of energy. So there are a lot, and more importantly, from an operations perspective, how many kilometers do you run every day? The more you run an EV, because the running costs are lower, the more you save. So that's a very important insight why fleets make sense in commercial fleet applications. So it depends. The answer is it depends. There are countries in which this is true. There are countries in which it's starting to become true. But I think the trend is that, okay, let me start to get my feet wet in the space so that by the time the costs come down, I'm in a position to be able to scale rapidly. So a lot of especially the marquee fleet operators today, you have announcements from UPS, FedEx, and these kind of really large operators why they have made very clear commitments to move towards electrification of transport. And they're starting to put their pilot programs in place to learn how this works and what are the learnings and how do you manage that. So that's starting to happen today. So, but yeah, I think the important thing is that personal vehicles in general run maybe 30, 40 miles, but fleet vehicles may run more than 70, 80 miles. So that's more than 100 kilometers every day. In the case of taxis, it might be even 200 kilometers or 160 miles every day or more. So that's the reason why fleets start to become more attractive from a electrification perspective. So we will
Got
be in
it.
the course. Yeah,
Yeah, there's another question from Micah in the chat.
right.
Micah says, isn't part of the challenge that many commercial fleet owners lease rather than own their vehicles, and therefore the TCO isn't value they can capture?
And therefore the TCO
Isn't value that they can capture?
So in the course, we will be looking at both asset light and asset heavy models. So that is the first thing. Regardless of whether you do, if let's say if I'm a operator of fleets and I am leasing a vehicle from a fleet leasing company, I would still look at my total cost of ownership vis-a-vis running an equivalent fossil fuel vehicle. It could be diesel or it could whatever be the options that you have available. But that comparison would always be there. So even if it, in fact, many satellite fleet operators, classic example, Uber. Uber doesn't own any fleets, but they have a very important target and commitment. Amazon, for that matter, they don't own fleets, but they are committing that they're going to move towards electrification, even if their fleet operators have to lease the vehicles. Because even when I take that, what I mentioned, that your capex, finance cost, insurance minus the residual value, that's what is going into a fleet lease calculation. This is true regardless of whether it's ICE vehicle or EV. So you have a residual value calculation that comes in. So regardless of this, you would basically look at your total cost of ownership during the period of leasing your vehicle. And if it starts to go below your total cost from an ICE, you would be interested in doing that. There are other operational challenges from charging infrastructure and all that fun stuff. But in principle, the principle of TCO being a key driver of a decision driver is very valid, regardless of whether you are an asset light entity leasing vehicles from somebody or you are an asset heavy player who buys and owns your own vehicles. In both cases, this works. So very quickly, one of the aspects of fleet operations is that it's very dependent on a multi-stakeholder environment. So we kind of need to take into account what is the policy and regulation, especially in an EV case today when it's a nascent market. Policy and regulations play an important role. What's the availability of finance? What are the role of utilities in your market? How do real estate and municipalities come together for providing charging solutions? What's the kind of OE products and the backup service and warranties that you're coming from them? They typically manage service through a dealer network. So what's the availability of that in the particular market that you operate in? Then the operator maybe, I mean, if you are a fleet owner and but you are providing your vehicles to somebody else to operate, so there could be the operator's role in terms of how retraining a little bit in terms of your driver behavior becomes important. And of course, the end customers, what's the value to them? Are you able to pass on some cost benefits to them? The last bit is around resale markets. Today, one of the important challenges that that faces this market is being a nascent market. If I were to buy a regular ICE vehicle, I know that after 4 or 5 years or whatever 10 years, I can expect a certain resale price for my vehicles. But that's becoming a challenge, and that also depends on the battery price evolution and all of those. So resale markets become an important consideration when you're thinking about, if you are a fleet owner, how do you think move towards commercial electrification of your fleets? So I'm going to pick three. I'm going to talk about a little bit about the OEM space. Going to talk about how finance and operators work together, and basically try to highlight some of the issues that come up in this space. So OEMs are pretty much the technology arbiters for EVs today. So they control what technology comes out into the market. And they're starting to think. Earlier, the bulk of the focus from global players was on personal mobility. But now they're starting to think about what does electrification mean for fleets as well. So very quickly, I mean, we many of you probably know this, but I thought I'll quickly touch upon the key components of an electric vehicle. You have the battery pack, you have which stores energy. You need to replenish the energy, so you need to have a charge port and an onboard charger. The onboard charger converts the AC from the grid to DC, put it into the batteries in a controlled manner. You have a 12 volt that might be there to supply the auxiliaries, your headlights and horn and other kinds of peripherals. You have the motor which actually spins the wheel, but there's also a motor controller which takes the energy from the batteries depending on how the person is pressing the accelerator pedal. and which direction it has to spin in. So it will take energy from the batteries, put it into the motor, and while braking, it can take the energy from the vehicle and put it back into the batteries, at least some of it. And you need a thermal system both for cooling off the batteries and the motors and controllers, as well as for cabin cooling. So these are the main elements. In terms of what differentiates, what is intrinsically different about an EV, I think obviously there is zero tailpipe emissions. You have very good standstill torque. Therefore, you don't need gear shifters to move a vehicle through the speed curve. And they're generally a bit heavier because of the battery pack that adds a lot of weight to the vehicle. So it sometimes in the commercial vehicle case, your weight class may change. So that's something that we just need to be careful about. Or your payload carrying capacity could be impacted. So that's something to just keep in mind. The new types of safety considerations, lithium ion batteries, basically, when you say lithium ion, there is an oxide of a metal that is already always the cathode, which means that there is oxygen packed into the cathode of the battery. So if it flames, you don't need oxygen from outside to sustain the flame. It just continues to burn. So it has new kinds of thermal considerations and safety considerations. Refueling times relative to what we are used to with the ICE world is longer. So there is a little bit of concerns around that. And the central point about high capex and low opex. So that's something that impacts them as well. But from the heart of the electric vehicle obviously is the battery, and that has several kinds of impact on a fleet operations as well as financial aspects. Firstly, you have a capex impact. There is an upfront cost that goes up. Then the second thing is, how long is my battery going to last? And what will happen? What will it cost if I have to replace the battery? What is that going to cost? And if I'm doing a lease program, so someone asked the question, so how do I calculate residual value of a used electric vehicle? Or what should be the electric? If I'm a financier financing an EV, what should I expect any RV to be? I need to project in future in a market that still doesn't exist. So those are the challenges that come in this context. From an operational perspective, how much range can I get? Range can vary. We'll see about that. That will it be able to fulfill the duty cycles of my fleet operations? That becomes an important question, because you will see that the number that is given from certification may always not be what you will actually get. And lastly, recharging time. So, I mean, if my vehicle is going to be standstill while it should be running its daily duties, I'm losing money. So I don't want to be doing that. So how much time will it take to recharge? Where will I recharge? And so on. So those questions become important. Safety, of course, is something that you need to just rethink it. It's not like fossil fuel vehicles don't have safety issues. It's just that we have learned to deal with that. So similarly, we need to learn how to deal with the issues that come up with an EV. So on the range bit, what I was talking about, so you take the same vehicle, you have this Hyundai Kona. I've just picked up an example. It's not intended to be I'm promoting a particular vehicle or something. It's just an example that there is the same vehicle, identical battery pack. It was tested in 3 different markets with 3 different drive cycles, the European WLTP, the US EPA, and the Indian MIDC. And you can see here the numbers. The range is very different depending on which drive cycle is used. What it really means is that depending on the test condition, your real drive range can vary, which means that in your real world operations as well, you can have a significant variation of drive depending on a host of factors. For example, traffic patterns. If you have a lot of start-stop traffic versus you have, in the case of buses, let's say, for example, you have what are called bus rapid transit routes, which are like expressways running through a city. So you have very steady traffic. So you may have a different uh, range from a BRT bus. And again, from a highway pass, which is doing high speeds, your range drops drastically. So you can have a very different range depending on what kind of a driving pattern and traffic pattern that you encounter. How many people or how much of goods is being carried, that has a significant variation impact on the range as well. Ambient temperature can affect in different ways, and driver behavior. These are the 4 factors I've picked up, but there are a couple of others as well. So I'm just showing an example here. What's the real world range versus rated range, whereas the temperature changes. So there is typically, as you go lower and lower or very high temperatures, your range can drop. So between 0 degrees and say 20 degrees. So typically batteries work well, especially if they are not actively managed, thermally managed, then they work very well between say 15 degrees to say 30 degrees, or in that kind of a ballpark. But as your temperature drops or increases, as your temperature drops, your electrolyte becomes more sluggish, and therefore your capacity to hold charge goes down. As it increases, your internal resistance goes up, and again your range can drop. Plus, if the cabin is cooled, then of course you consume a lot of the stored energy in the battery to cool your cabin or cool the components, and that again intrinsic wastage of energy happens. So your range can drop very significantly. Similarly, so this is basically what I was talking about. So lower temperatures will impact your power delivery, high temperatures impact life, and both extremes can cause you a longer time to charge. So all your operating patterns can go haywire depending on how the battery performs at different temperatures. Of course, this may be a little less of an issue if the battery is better thermally managed and there are better charging strategies that are followed to make sure that the vehicle is conditioned. But in general, if this can be something to keep in mind. Life. I think this is one of the biggest concerns that people have when they are thinking about adopting an electric vehicle. So in terms of the number of charge discharge cycles that a battery can go through, it depends on the chemistry, it depends on the design, it depends on how it is used and a variety of other factors. But you typically, the kind of a norm is that till around 80% capacity. So battery capacity will drop. That's the reality of batteries. So typically what that means is that if you are today, when you have a brand new vehicle and you're able to run them for 100 miles, maybe after N number of years or X number of miles, you may be running them only for 80 miles after a full charge. So that's basically the 80% capacity or 20% capacity drop that typically people say may be a point at which you may need to change a battery, maybe, maybe not. If your daily operations are still able to sustain, you can continue to use it. But at some point in time, there is something called a knee point at which the battery capacity drops very sharply, and therefore you will have to replace that pack. Yeah, typically it's a replacement thing. So it goes on for a recycling purpose, or you can use it for, before that, if you want to change it, it becomes a second level. When do I do it? How much is it going to cost? All of these are going to impact your operational viability, and that's an important point to keep in mind. The other thing to keep in mind, for example, is what's the warranty that is offered by an OEM. So typically when a financier wants to finance an EV, they would look at what's the warranty on the battery, and is my financing term less than or equal to the warranty of the battery. That's something that bankers will typically look at, because for them, they don't want an important component of the vehicle to be taking any risk on their financing. So that's the first thing. The second thing is, how do you measure the assurance on battery durability? I mean, it's an important element of that. So because that will impact, if my battery is durable, then can I get enough cash flows to make up the cost of the battery, the replacement battery? Do I have that ability to do that? Is my battery going to last me long enough? And is the rate at which we saw there is a slope at which the range drops, how will that affect my operational performance? So what is is it going to drop sharply and then stabilize? Is it going to gently slope down? What is that looking like? So that's something that becomes an important metric as well. So in the course, we will see how to look at battery warranties with a little bit more of a finer grained look. But this is just an example of how not to write a battery warranty. This was taken from an actual contract. I will not name where and when, but it says the buses will have an autonomy of at least 260 kilometers per day for 8 years. What's wrong with that? 260 kilometers per day for 8 years. It's completely very vague. Which route? What kind of driving pattern? What's the kind of loading? Are there any passengers in the bus, or is just the driver sitting and driving around? Under what driving patterns? And is there an air conditioning being used, or is it not being used? There's so many different nuances that one needs to keep in mind when doing this, that from a fleet owner's perspective, learning how to read a good battery warranty clause becomes an important metric. I'll move quickly to the business model side of it. So this is basically where you're talking about, as a business, your risk reward relationships. So a business model basically defines how you make money. What does a business own? What does it do? Who's my customer? What's the value proposition I'm creating for them? Who pays to whom and when? And what risks does it take on? Broadly, these questions kind of define a business model. In the case of commercial fleet applications, like I was saying earlier, you may or may not own assets. Uber is classically an example of an entity that does not own assets, but there are many taxi companies that do own their own taxi fleets. They may or may not employ and manage drivers. They typically move people or goods, and there is a user or customer who's needed. So that's sort of why they are paying for it, right? So now, if I were to take two examples, a New York taxi and an Uber as two examples of how the same service can be offered in two different ways. The asset owner clearly in one case is a corporate, in the other case it's an individual. The activities that the company performs in the case of Uber is basically a technology platform matching the supply and demand of drivers and passengers. But in the case of a New York yellow cab, they're actually managing assets and they're leasing it to drivers who pick it up on whatever contract. The revenue model, basically Uber makes money from the passengers who are paying for their rides, whereas the NYC taxi would make money from the drivers. So there is again a difference in the way the whole thing works. Scalability, of course, becomes very different. When you're asset heavy, scalability is harder in general. When you're asset light, scalability becomes easier. And the key risks that you're taking, in the case of Uber, they are not taking any risk from the asset owner's perspective. So there is mostly the ridership demand risk. There are many others. I'm just kind of picking one here from just to highlight the point. And in the case of the taxi company, you're obviously taking the risk of the asset as well. In addition, if there is a drop in ridership demand, your drivers will also not turn up, which is what has happened, let's say, during COVID. And so therefore, indirectly, there is an impact on your operations as well. So what does this mean for electrification? So from an asset, so if let's say I'm an Uber and I want to deploy EVs in my fleet, I have to somehow incentivize my drivers to adopt EVs. It's not like I can buy the EVs and I may be able to do it like Ola in India has the model of owning assets and giving it to their drivers, but that's not the Uber model. So if you are an Uber, you're sort of wanting somehow to encourage your drivers to do that. But drivers generally are people who may be very risk averse. They may not be the people who would be at the forefront of adopting a new technology. So it's more expensive, higher technology risk, resale value risk, a lot of risk that as an individual, they may not be interested to take on. Now, if you have to give them financing, the bank will look at the standing, the financial standing of the driver, which may not be very great relative to a corporate, and therefore the cost of finance may also go up. Charging infrastructure is something that, regardless of which model you are in, you will still need to figure that piece out because it's still not as prevalent as one would like it to be. So that becomes another issue to be addressed. And lastly, who benefits? There's a very subtle point that I've been observing that EVs save you cost, but who takes that cost arbitrage, who takes advantage of that cost becomes an important thing. I'm seeing many cases where, let's say, I'm just throwing an example here, let's say Amazon is very keen that its operators adopt electric vehicles for their last mile deliveries. The way they are doing it is, let's say that if an Amazon was paying X dollars per delivery to a fleet owner or a last mile delivery company, they are now giving less than that because they're saying that the other guy is anyway going to save on EVs, and therefore I'll start paying them 10 cents less or 20% less from my cost. So Amazon is taking advantage of the electrification, leaving nothing much for the other guy. I'm just using Amazon as an example, but that's what has kind of happened. So who is taking advantage of it has a huge bearing on who's able to adopt EVs. So lastly, very quick one, financing. There's many different ways you can do asset financing via equity, debt, you're doing it via leasing, via project finance, PPP models, municipal finance. There's a new model that's basically the asset holding company that's coming in. But the current reality is that many of the bankers are risk averse to fund EVs, not so much in developed markets, but a lot more in developing markets. The bankability of the owner, we spoke about that. The products are new, residual value risk, contract duration. I mean, will the contract cover the period of the vehicle loan? Operational feasibility, will it fulfill the duty cycles, and are there charging infrastructure challenges? All of these are kind of bumping up your cost of finance. Summing up, so basically you have the opportunity to lower the total cost of ownership, but you're going to have a whole bunch of challenges: higher capex, how many miles it will run, charging time, batteries will degrade in a strange fashion, figuring out charging infrastructure. Your ability to benefit from EVs will depend on your market power, Financiers may not be comfortable, unknown residual values, resale markets, and technology is changing rapidly. So unpredictability is introduced into fleet applications, which have a material impact on financial implications as well as operational matters as well, if you are a fleet owner. So the whole central problem that we are going to be talking about in the course is basically how do I introduce a range limited, refueling constrained, unknown residual value vehicle into fleet applications that need to run very predictably, high kilometers a day, and make money for me. So that's the central the thought process that will drive the whole course design. So very quickly, I'm going to cover what we are going to talk about. The first, this is 12 sessions. The first one is more introductions and talking about the course, and there'll be a project for each of the participants. So we'll be talking about what's the project that they have to undertake. Then you basically, what is driving electrification and what's the environmental impact? We'll be starting from that perspective. We are, after all, a climate change group. We'll be covering technology in two parts, because I do believe that understanding the nuances of how EVs behave, how they work, how to manage them is an important element of being able to successfully run a fleet operation. So I'll be covering that in two parts over two sessions. Then there'll be a guest lecture on electric vehicle technology. Someone who's a practitioner in the space would be popping up to speak about that. Then we will talk about business models. I touched upon it very briefly, but we'll kind of dive into a little bit more detail. And one thing that I did not touch upon is public transit. So there'll be a little bit of conversations around that. And we'll talk about someone who's actually doing business models and how they are seeing this. Then we'll speak a little bit about unit economics and total cost of ownership. How do you assess financial viability? Are you ready from a financial perspective to adopt EVs into your fleet? So what drives that? What are the sensitivity factors there? We'll talk a little bit about, if you are not so much interested in the fleet vehicle side, but on the charging infrastructure side, what are the different business models and pros and cons of that? We'll have an EV guest lecture on policy, and lastly on policy, I'll dive a little bit into policy considerations, and finally putting it all together. So that central problem that I faced, understanding all of these different aspects and kind of putting it all together into an approach for transitioning to fleet. So that's basically the course. I'll stop at this point. Happy to have questions and comments, anything else that you would like to share.
Thank you. Thanks a lot, Karthik. And everyone, please free to drop in any questions if you have in the chat, or you can just unmute yourself and ask your questions. Meanwhile, I just wanted to mention one other thing. We are offering a special pricing to everyone who has signed up for the webinar and has put in the effort to join the webinar. The program starts on July the 12th, that is the coming Monday. If you're interested, and if you put in the discount code EV25, we will give you a straight 25% discount. There are other financing opportunities, scholarship opportunities as part of the application. So if you are interested in the program, please do apply before July 10th. The program starts next Monday. Once again, the discount code is EV25. Yeah, any questions anyone has, please drop them in the chat. I see one question here, if you want to take that, Karthik.
Yes, sure. So the question here is, what about the impact on the grid when all of these fleet EVs plug in to recharge at the end of the day, when solar is starting to decrease, go away? Yes, I think regardless of whether the fleets or even personal mobility, the impact on the distribution grid definitely needs to be considered. There is absolutely no doubt that the challenges on the distribution, the utilities, the local transformers' ability to be able to manage that is an important consideration. And that would need to be addressed along with your local utility to figure out how that's going to be managed. Yeah, I think from a supply perspective, it is not such a big deal. And in fact, I think with fleet applications, so for example, depends on when your fleets are inoperative. Public transit buses, for example, typically they would recharge between, say, 12 midnight and 4 a.m. That's a brilliant time to, from the grid's perspective, that's a very happy hour for them. So yeah, so that makes a lot of sense. But still, I mean, if you're going to have
Sorry, I think Karthik is having some connectivity issues. Just checking. Yeah, Karthik is here. Karthik, if
Sorry,
you
there
can just,
was a loss
yeah,
of connectivity at my end. Sorry.
you're in mute, Karthik.
Yeah, sorry. So there was a loss of connectivity. I'm sorry how that happened. But yeah, so that was basically what I was saying, that you do need to study the impact of your uptake on the local grid to understand what that would mean.
Mayur, to your question on will this course become an incubator lab for new business opportunities in the EV space? As Karthik mentioned, there's a lot of coverage on how to actually run a business and business models and everything. Apart from that, what you will get, of course, is a network in the EV space. At Terra.do, we are also working on some incubator opportunities across our different courses, but to be very specific, there's no specific incubator component to this program right now. Does that make sense, Karthik?
Yes. But I think the point is to be able to plug into a broader network that could then lead to support.
Yeah.
I see a hand raised, Dinesh. You are speaking on mute.
Yeah. Sorry,
Uh,
Karthik, if you want to take that question from Leander, then I'll go to Rajat.
Yes. Which benefits could B2G bring to fleet owners with energy arbitrage or peak shaving abilities? Could the benefits be expected to be high enough to offset battery degradation cost? Um, it's up in the air right now. To be honest, V2G is more at this stage, in the stage of technology prove out. Business models are still being worked out. There is a lot that depends on as battery prices go down. Definitely, this starts to become more and more attractive. It depends on what time of the day at which you're offering the energy from the stored battery pack back into the grid. So there will be a time of day arbitrage to be had, and therefore that would impact. So the answer is it's not a clear answer just yet. It's still being worked out. But in the long run, it's expected that there will be a cost that is paid, which is yes, it has to be sufficient to cover the cost of degradation and also make arbitrage for the end utility as well. That's the hope.
Yeah. Just for the benefit of everyone, V2G is the concept of vehicle to grid.
Yes.
Uh,
Right.
Rajat,
Yes.
please go ahead.
so, hi Karthik, this is Rajat. I am currently working with the Volvo Group in India, and I've been into the commercial vehicle space from the last 16 years now. I'm closely associated with the logistics industry in India. So, my question is related to two things. One, I'll ask the first question. The one, it is related the warranty clause that you have mentioned in which is in relation with what happens currently in the industry, that the warranty clause goes with the vehicular warranty, which is primarily the driveline warranty of the vehicles, which include the engine, gearbox, and the differential. I'm saying about India, specifically India. And second is the warranty of the body warranty or the entire vehicle warranty that we follow. But when it comes to financing of the vehicle, none of these clauses are being taken care by any of the financiers here in India.
Yes.
So, you said it is going to be most important as far as the EV is concerned. So why so you are mentioning
Yes,
about
yes. So typically, if you look at the and let me stick to buses. It's good that you're from Volvo, so it's good to speak about buses. So if you look at typical bus total cost of ownership models today,
yeah,
um,
we do. I'm sorry, but TCO is at our day-to-day life routine. That's why I am very much interested in doing.
yes, sure. So, so today, if you look at the EV bus TCO, depends on the market. I mean, so there are markets in which it's starting to become break-even periods are in about 7 to 8 years. There are markets in which it's 12 years. There are markets in 14 years. So, from my IFC perspective, I look at different developing markets. So there is a wide spectrum of markets. Break-even points on the TCO side, right? Now, if my, so we are, for example, at IFC, we are doing financing of public transit networks for, let's say, a 14-year loan. Now, if my battery warranty typically would be for about 7 years, that's kind of a norm that has kind of come in into the public transit space. Now, if it's a 14-year loan and my battery warranty is for around 7 years, I need to make sure that there is a second replacement battery that comes in. I have to figure out the cost of that and so on. But I need to know within that loan period, how many batteries am I going to consume? Is it just two or is it three? What is that? And how do I read that? From a financier's perspective, how do I read this thing? Because that has a huge impact on my financial cash flows. Being an important, by the way, people say that, oh, battery prices are coming down to below $100 and therefore OEMs don't sell you at cost, especially spare parts. Spare parts, they pack a huge amount of margin. So if you are having a battery pack price today at $100 per kilowatt hour, the OE price to you when you are replacing your battery maybe $150 per kilowatt hour or whatever number that they choose to plug in. And because they know you have a captive customer, he can't go anywhere and else and buy a battery, so they will fleece you for that. So the price at which the replacement is going to happen becomes an important consideration of the total cost of ownership. And that in turn has an important consideration from a financier's perspective. What is my returns going to look like? What are the risks that I am taking on a future cost of the vehicle? That's the reason that the battery replacement cost, and therefore when is the replacement going to happen, which depends on warranty, becomes an important consideration.
Because I'm little doubtful, Karthik, because what happened is in the India, I'm not talking about the public transport here. What I'm talking about is that the most of the private players in the transportation industry, the financing tenures does not go beyond five years in the current market scenario. So and when I see your the cost of the TCO and the slide that you were showing at that point of time. So in that slide, you said the savings from a EV vehicle start from the fifth year.
That was just
Am
an
I?
example. I just picked an example randomly, but it may be depend. It depends on for two-wheelers, for example, in India, it is 18 months.
No, I am sticking myself to the commercial vehicle space
No, no,
only.
I'm
So
saying two-wheelers used in delivery markets for fleet
yes, yes.
applications. Yeah, yeah.
So I'm little concerned that like, how the 5 year tenure you will be able to make out the cost of the EV vehicle as well as to make money out of it, and especially the warranty clause, because there are certain things which is um, I say honestly speaking, I'm the ICE guy. I won't understand electric vehicle. And that's why I'm in this entire discussion. So I just wanted to know like how we are coping up as an the industry as such, or the developments which is happening. So how we can cope up with this, because there is no tenures available in the commercial vehicle financing. If the cost started coming or the savings started getting after 5 years, it will be really tough. This is my question. I mean, this is what the initial inhibitions which is coming into my mind as far as the EV space is concerned.
I'm not very sure I got the question exactly. So are you saying that, okay, so I made it very explicit that I was talking about a bus example. So
Yes.
in the bus case, financing does go for longer tenures. Take it from me because I work on that. And even in India, it's typically a 10-year, under FAME 2, it's a 10-year contract. So it goes for 10 years. So, and the the banks who are financing the people who are running the buses, they have to take that kind of tenure into account when they are financing those operations. So, EV bus and large commercial vehicle financing can go for a longer tenure. I'm not sure about the rest of your question. Maybe we can connect offline if you don't mind.
Okay, thank you.
Yeah. Okay.
Yeah, thank you.
Have you seen OE business models decoupling the components, leasing the battery? Yes, I have done that myself. I created the first battery lease program in India and ran that. Longer O&M contracts to purchases, that depends on one of the risks that I mentioned in the financing questions was the contractual risk. So this is classically the problem that you may have. You may have an entity that has operating fleet operations contract for their client. Let's say it is for 3 years, but you need to finance the vehicle for 5 years. And there is clearly a mismatch. Usually this is not so much of a risk in the ICE world, but with EVs, some financiers are frowning upon this. So this becomes a challenge, and therefore in certain cases now, like we are talking to the players to let's say, for example, I'm not trying to pick on a name here, but Amazon just happens to be a large player. So the Amazon's contract with a 3PL player, if it is not matching the tenure of financing, then there are conversations happening about how can they help to extend that. It's not that straightforward, but that's something that can potentially be looked at as a solution to match the duration of the contract with the duration of the financing. That becomes important. But leasing of batteries, yes, it is. Leasing of batteries is a little bit more operationally challenging compared to leasing the entire vehicle. So leasing of batteries is something that, for example, Nissan Leaf was launched with a battery lease program. Renault Zoe launched with some of that, but they have withdrawn that. It's operationally not that straightforward. People also have a lot of tendency to want to own the entire asset. So vehicle leasing is something that people are definitely looking at a lot more than battery leasing per se. Theoretically, it makes sense, but practically there are some challenges in that.
Okay. I don't see any other questions. We are just upon the hour. But thank you, everyone. Thanks a lot for joining. Thank you, Karthik, for your valuable inputs and everyone for your questions. We hope to see some of you in the program for more of these discussions, and wherever you are, have a good day or good night.
Thank you. Thank you for joining. Thank you very much. Bye-bye.